All right, so this is still May 2018, question number 9. All right, and this is the B part of the question. It says the diagram below not drawn to scale shows a circle with center O. The points A, B, C, and M are on the circumference. All right, so that makes ABMC a cyclic quadrilateral. The straight line CN is a tangent to the circle at the point C and is perpendicular to BN. All right. We're to determine, given a reason for your answer, I, angle ABC. So we're going to identify angle ABC. This angle here they want us to find, I'm going to call it alpha. Now, finding that angle is easy if you recognize that this angle is 90 degrees. That angle is equal to 90 degrees because it's an angle in a semicircle. So I would start by saying to the examiner that angle ACB is equal to 90 degrees. It's an angle in a semicircle. So once I know that that one is 90, I can then say that alpha, which is angle ABC, is equal to 180 minus 90 degrees plus 58 degrees. And this is the interior angles in a triangle. So this would be 180 minus 148. So the angle here is 32 degrees. So this angle here is 32 degrees. All right, next, what are we asked to find? Next, we're asked to find angle CMB. Angle CMB, CMB, that's this angle here. All right, and that is also easy to find as long as you remember that the angles of a cyclic quadrilateral are supplementary. They add up to 180 degrees. The angles in a cyclic quadrilateral are supplementary. They add up to 180 degrees. So this angle here and this angle here, they're opposite angles in a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral are supplementary. They add up to 180 degrees. So I'm going to say angle CMB is equal to 180 minus 58 degrees. They are opposite angles in a cyclic quadrilateral. They are opposite angles in a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral are supplementary. So angle CMB is 122 degrees. Then we're asked to find angle, and this is the last angle, angle NCM. Angle NCM. Let's identify it. Angle NCM. This angle here. And it's not difficult to find. This is 122, I think. You see this angle here, the 122 degrees, it's actually equal to 90 plus the angle at C. Because the exterior angle of a triangle is equal to, and to tell honest truth, we didn't have to go that route, but it's the easiest route actually to go. We didn't have to go that route, but it's the easiest route to go. The angle here, 122, is equal to 90 plus whatever this angle is. So let's call it theta. The angle theta plus the 90 degrees equal to the 122 degrees, because the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So I can then say angle NCM, angle NCM is equal to 122 degrees minus 90 degrees. Why? Because the exterior angle of a triangle is equal to the sum of two opposite interior angles. So in other words, the angle NCM plus 90 equals 122 degrees. So this would make it what? 32 degrees. All right, so the angle is 32 degrees. I think that's the easiest way to find it. Let's go back to it. All right, the fact that this is 32 degrees, it's sort of causing me to wonder if we could have gone a different route, but no, that is it. The angle is 32 degrees. The angle theta plus the angle at N, which is 90 degrees, is equal to 122 degrees. The exterior angle of a triangle is equal to the two opposite interior angles. All right, and so that's the end of the question.